Okay, so we are live. So yesterday, I was unable to solve this question. Search in a rotated sorted array. So we'll continue from this question itself. So basically, we are solving 150 questions from LeetCode sheet. So we are now in the binary search topic. So basically, today we will be targeting these two problems. First one is search in a rotated sorted array, and second one will be time-based key value store. So let's just start with the first problem. Hmm, okay, so let's just reset it. Okay, so let's see yesterday's submission. So we got wrong answer. Okay, so basically we can have two cases. First one is this. And second one is this. Okay. So in first approach, we can find the middle element. The minimum element. Suppose if we are able to find this minimum element one, we can simply say that the this part is sorted independently and this part is sorted independently, and we can search for our number if it lies in this range, and if it lies in this range, then we can search in this range. So first part is first approach will be this is approach one. Find minimum element and then split at minimum element, apply binary search to both parts. So actually we don't need to apply binary search to both parts. We only need one path. So okay, so we need to find minimum element. So for example, if our mid lies here, okay, one case can be this. Okay, so if our mid lies here, so our this part will be shorted and this part will not be shorted. Okay, suppose if our mid lies here, so our this part will be shorted and this part will not be shorted. Okay, okay, let's first take size of the array, which will be nums dot length, and our starting index will be 0, our ending index for the binary search will be this. Okay, so I'm defining a variable min index. So if a situation occurs where my s becomes equal to e, so that will be my minimum index. Okay, So let's just start with this condition itself. So first condition is if my mid element, this mid element is greater than, sorry, is smaller than this element, is smaller or equal than this element, uh, E, then my this part of the array is sorted. Okay. So in order to find the minimum element, I will be moving my start pointer to this mid position. Okay. Hmm. Else if my mid number, if it's greater than or equal to my left number, which is start, so in that case, in that case, two cases arise. One is okay. Mm-hmm. We are looking for the minimum element in the array. So if it's greater, uh, suppose this was the example 6, 7, 1, 2, 3, 4, and 5. So middle will be this, and this part array would be shorted. Our minimum is on this side. This part of the array is shorted, so mid is this. Okay. Hmm. We can have one more case. That is this case. So here my mid value is greater than my end value, and for this case also, sorry, smaller than my end value. In this is the similar case. So I will move my h pointer to this position. So my mid position is smaller than or equal to my e pointer to the mid. Okay. Else the this case remains. In this case, my mid value will not be smaller than this value. So I need to move my s to the right, mid plus 1. So at the end, my loop will terminate when s becomes equal to e. So that will be the index of my minimum element. Min index would be s. Okay, return 0. Okay, let's try printing our minimum index. Okay, so for this case, our minimum index is 4. 0, 1, 2, 3, 4. Okay, so we have found the minimum index. For case 2, also our minimum index is 4. For case this, our minimum index is 0. Okay, so basically we have written the code for minimum element, means we have found the minimum element. So suppose we have found our minimum element, we will split our array uh, at minimum element. Okay, so our minimum element is this, and it's splitting the two arrays. So now we either we have to search our target in this array or in this array. Okay, so if my target is greater than equal to nums of s. Okay, s is my middle element now, middle index. If my target, suppose target is 2, if my target is greater than equal to 1 and smaller than equal to this end index, target is smaller than equal to nums of n minus 1, then I will be sure that my target will be lying in this part. Okay, so in that case I'll be returning find a target, a function which takes nums array and starting index and ending index as the input and target as the input. It will return the answer. Otherwise, if my target, so this is my minimum index, and now in this array my target is greater than equal to nums of 0, and my target is smaller than equal to my nums of s, but I have to make sure, sorry, s minus 1, I have to make sure that my s minus 1 is greater than 0. Okay, so in that case I'll be using same function. I will only change parameters, so here parameters will be 0 and start minus 1. Basically this s is representing index of minimum element. Okay, so now I need to implement this find target function. Find target into nums, int starting index, into ending index, and in target. So while my starting index is smaller than ending index, mid will be s plus e minus s by 2. If my nums of mid equals my target, then I can say I have found the target, and I can return m. And if my nums of m is greater than my target, means my middle index is greater than target. Suppose this is my middle element 3 and my target was 1. If it's greater, then I need to move e pointer uh, to mid minus 1 position. Else I will move my start pointer to m plus 1 position. If at the end I will return minus 1 if I haven't found the target in the given array. So I think this approach will work. Okay, so basically, let me summarize. So in this approach, we have found the minimum element first, and then we splitted our array into two based on the minimum element, and we are finding our target in the both the arrays. So let's just run. So okay, so we have got 4 for this, 0 0. Okay, so at the end we need to return minus 1 if we haven't found our target in any of these values. Okay, so yesterday some of the test cases were failing, so let's try that out. First one was this, and other was this. So let's try running these test cases. So yeah, let's try submitting our code. So we have got a wrong answer. Expect output minus 1. Expected, okay. Hmm. Okay. So this is the test case. We need to find 3 here. So let's see if our target index is correct or not. Sorry, minimum element. So S is our minimum element. Okay, so our minimum element is at index 1. Okay, which is correct. 1 is the minimum element. So if our target, which is 3, is greater than or equal to nums of S, okay, which is true. No, no, no. This is not true. Nums of s is this value, so this condition will not be fulfilled. If our target value is greater than or equal to, okay, greater than equal to 0 means our s minus 1 can also be 0. So I think this will work now. Let's try submitting our code. Okay, we have got a 100% faster solution. Okay, so I think we need to discuss one more approach. One more approach was regarding Hmm, I think I have pasted it earlier. That was it. Using ChatGPT, I have found that approach. Okay, so this was the approach. This approach I have got from ChatGPT. So basically, what we are in approach which I have explained, I was using two binary searches. First one was to find the minimum element, and second one was to find the target element in that partition. So but in this approach, okay, so in this approach, what we are doing that we are checking whether middle element is equal to target or not. Okay, so otherwise we will be left with this case that our nums of s is smaller than our middle element, which means our left half is shorted. So this is the case where 5, 6, 7, 8, 1, 2, 3. So here our middle element is 8. So mm, and starting element is 5. So basically 5 is smaller than equal to 8. So this means that our this part of the array is shorted. Okay, so if our this part of the array is shorted, and so what we are doing, we are checking, suppose our target is 2. So first we are checking if our target is greater than equal to s. Yes, it's greater than 5. And our target is smaller than middle. Means simply we are checking whether our target lies within this range. If our target doesn't lie within this range, if it lies within this range, then we will move our e to this position. So this will be our new array. Otherwise we will consider this array. Okay. Okay, so if this condition doesn't satisfy, means if 8 is not smaller than 5, suppose if we put 0 instead of 8, so now our 0 and 5, so 5 will not be smaller than or equal to 0. So this will give us false. So basically this condition will not satisfy. So this will mean that our right half is shorted. So this part is shorted. So we will look for our target in this part. Suppose our target is 2, so we'll check if our target is greater than mid. Yes, our target is greater than mid, and our target is smaller than this. Yes, our target is smaller than this. So we'll consider this part of the array. Uh, sorry, we'll remove this part and we'll consider this part of the array. So that's how this approach will work. So I'm just pasting this approach in the chat box. Okay, so I think this is okay. So I think this was pretty good question. Okay, so next question is time based key value short store. Okay, so this question says time based key value short. So the question says design a time based key value data structure that can store multiple values for the same key at different timestamp and retrieve the key's value at a certain timestamp. Okay. Implement the time map class. So this is time map class. Time map initialize the object of the data structure. Okay, so this is our constructor. So basically constructor, we can say, is a function in the class which runs when our class gets created. Okay, so we are given a constructor which will initialize our object. Okay, so void set is a function that stores key with the value this and timestamp this. Okay, so we need to store a key, a value, and the timestamp at which this value was stored in the uh, against this key. Okay, so now when another function is get function. So get function will take key and timestamp. Okay, returns a value such that set was called previously with timestamp underscore previous times to. Okay, if there are multiple such value, return the value associated with largest timestamp. If there are no values, return null. Okay, let's see some example. So we have initialized our time map. Okay, so we have set, we have called set function. So in set function, our key is foo. Against our key, this is our key, this is our value, this is our timestamp. Okay, then we called get. Okay, So we call get for foo and one. So what get function does, it returns a value such that the set was previously called with time underscore previous value, which is smaller than equal to timestamp. Okay, so what we are returning here, we are returning bar. Okay, so basically what we are given a key f and a timestamp, uh, which is 1. So we need to find a key foo. First we'll find a foo key in our map. So this is our foo key. Now we will find the value against which the timestamp's value is smaller than and equal to 1. So this value bar exists with timestamp smaller than equal to 1. So we will return bar. So that's why we have written bar here. So again we have called get. So get with the foo and 3. So we will check if foo exists in our map. Yes, it exists. So we will look for a timestamp which is uh, which is just smaller than 3. So it is 1. So again we will return bar. Now we have called set. So in set we have against key foo we have stored bar and 4. Okay, so our key will remain this only, and this we will store another value. So another value is this. Okay, and this is the timestamp. Okay, so against the key fwo we have stored these two pairs. So now we are calling get. So we are calling get at 4. Okay, foo and get at 4. Okay, so we need to return, we will check first foo is exist in our, if foo exists in our map or not. Okay, it is exist, it is there. So now we need to check if there exists a timestamp which is smaller than or equal to 4. Yes, so basically we need to return if there are multiple such values, it returns the value associated with the largest timestamp. So there are two timestamps which are smaller than or equal to 4, but which is closer to 4 is this 4. So we are returning bar 2. So that is why we are returning bar 2 here. Okay, so next what we are doing is we are calling another get. Okay, foo 5. Okay, so we will check if a value exists. So same output we will be giving bar 2. So now we need to figure out that how we will be storing, means the problem basically is to decide what data structure will be helpful here. So against a single key I need to store multiple values. So I can think of a key value pair where key will be this value and values will be this. So against one key I need to store multiple values, and in that multiple values also, if I am able to store timestamp in sorted order, then I will be able to retrieve the value in log n time. So that is why this is a binary search question. We need to store these timestamp in a sorted manner. So for example, if I create a map of string, so basically this string is a foo, and against map I need to store some data structure which will have so this is value which will have a value and a timestamp. So timestamp is in int. Okay, which can store our int, and which can store this in okay, so I can store the timestamp instead. So in Java we have a tree maps. So in Java, tree map stores data in sorted values of the key. So we will, in this tree map, we will make our timestamp as the key. Okay. So we will use this map here. Okay. So this is our hash map of string and tree map. We'll call it as our map. Okay. So new hash map. Okay. So basically whenever our object for this class will be made, this map will be initialized, this constructor will be called, and this map will be initialized, new hash map. Okay. So basically tree map stores sorted keys, means according to sorted keys. So it will be storing timestamp 1 and 4 in sorted order. Okay, so I initialize the map. When the set function is called, so what I will be doing, I will be mat.put if absent against this key. I will be putting a new tree map. So this function will check if against this key tree map object is present or not. If it is absent, it will put a new tree map object. Okay. Okay. So I think this will work. Okay. So we have now what we will gonna do. We will gonna get this tree map.get, and in this tree map we will put our timestamp, and against our timestamp we will put our value. Void set key value timestamp. Okay. Tree map of intensity, tree map we key dot put. Okay. Okay, so I think this is correct. So now I need to implement my get function. So in get function, uh, if my map doesn't contains this key, I will simply return this value. Okay, that key is not present in the map. Else I'll get my tree map. So this is my tree map. Now in this tree map, I need to find a key value against a key which is just smaller than timestamp. Okay. So I think there is a inbuilt function in tree map. Int value is equals to lower bound equals to tree map dot, let's just google it, uh, floor floor value, lower bound, lower bound in tree map. Okay, so lower key is a function. So lower key we can use uh, the function lower, is it key? Okay, so lower key we need to find lower key, lower key than the timestamp. Okay, so if our suppose if lower key doesn't exist, then what our map gonna return? Let's find out. I think it will return null in that case. Hmm. Or null if there is no such key. Okay, so if so we will use integer object because it supports the null value. Primitives don't support the null value. So if my lower bound equals null, in that case I will return empty string. Otherwise I will return tree map dot get lower bound. Okay, let's try running it. Okay, so this was integer. So in case one, what we are doing, we are setting this value. Okay, now we are getting foo of 1. Okay, so why I am returning? This value returns greatest key strictly less than 2 key. No, 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 I don't want strictly less than value. I want equal value also. So what I'll gonna do is I'll gonna check if tree map dot contains key timestamp. Then in that case I will return tree map dot get timestamp. I think strict lower key. Okay, so we have found a submission. I think let's just ask from ChatGPT if it can shorten our solution. ChatGPT. Okay, write more readable and oops oriented solution. Here's more readable and oops version. Actually, I do have a application. कि कर क्या रहा है भाई, क्या कर दिया ये? Get where's our constructor? Constructor is here. So we have defined a private final map where time value store, key value store. Okay. So we have defined a class, public static class, inner class to represent the storage of a single keys, timestamps and values. Inner class to represent, so inner class to single key. Okay. Tree map. Okay, we have initialized tree map. Okay. Get floor entry. Okay. Okay, so instead of using lower key, we can use floor entry. Okay. Okay, so this is giving a whole to okay. बहुत ज़बरदस्त सॉल्यूशन दिया है चैट जीपीटी ने। जो हम यूज़ कर रहे हैं मैप एज ए की वैल्यू स्टोर, उसने बेसिकली उसको एक अलग ही क्लास बना दिया और उस पे जो हम ऑपरेशंस कर रहे हैं उसको ऑपरेशंस को सेपरेट कर दिया बिल्कुल। जैसे कि सेट के केस में की वैल्यू स्टोर डॉट कंप्यूट इफ एब्सेंट, की के अगेंस्ट में ये डाल दिया। ये हमारे पास वो वेरिएबल आ गया, मीन्स ये वाला वेरिएबल आ गया और इसमें सेट कर दिया हमने timestamp and value. Here are some more readable with better encapsulation and adherence to OOPS principle. Key improvements: introduce time value store inner class to encapsulate logic related to storing and retrieving timestamp values for a single key. Readability: use clear method names, set, get, and variable names for better understanding. Reduce logic complexity in the main class by delegating responsibility to inner class. Okay. OOP design separated concerns. Time map handles the mapping of the key to time store object while time handles timestamp related problems. Efficiency: floor entry float directly fetch the largest timestamp less than or equal to the given, simplifying the retrieval logic. Okay. If one can write this solution in an interview, so he or she will surely get a strong hire. So I think we will also be practicing some Java OOPS question to understand the OOPS better. So I think that is it for today. So we will solve this question tomorrow, and we will start with linked list, and we will solve these three easy problems tomorrow. Okay. Thank you guys.